Good afternoon, everybody. Normally, Robert Conrad would chair the meeting, but he has to apologize, so he can't be here. So I'm a last-minute replacement. You have to do with me this afternoon, but I think we got some fairly interesting sessions. Also saw a presentation from Patrick yesterday. Very, well, let's say a lot of ideology, a lot of drive behind it, making people, raising a lot of awareness in the room, and a lot of people leaving with a feeling of that we have to do something. We have to move, we start doing things. A lot of these presentations today is about doing things. It's about disaster management. I think we got two presentations on wildfire. Patrick is going to give a presentation on wildfire management, and Marc Castellnou also, from two different perspectives. Carlo is going to talk about landslides, maybe also a bit about flood risk management. No, just landslides, good. We also have GeoAvalanche, who will actually provide us with some data harmonization best practices. Francesco will do that on natural risk zones. And last we got Fabio, who will discuss or present a case about water emergencies and how we can deal with it through citizen participation. So very interesting stuff. I would like to start by inviting Patrick to the stage for the first presentation. Thank you. Oh, beautiful. We always like visuals beyond the visual. That's 3D.
So welcome, welcome to your world. You start with the full one. This is what you get to begin with. We'll just leave it here. By the end of this meeting today, you'll see what world we're left with. This is called sustainability, living off of our interests. Right now, we're eating into our capital at 1.5 Earths a year. So we're not going to survive this. There's not a chance in hell unless something happens soon. And we spend a lot of time here at Inspire talking about data, and then we start talking about more data, and then we talk about other data, and then we talk about data protocol, data access, data this, data that, data everything. Give me a break. It's time to stop talking about data. It's time to do something with the data. It's time to provide solutions with the data and stop complaining, stop fixing, stop adjusting, stop saying this is the way it's got to be, we've got to harmonize and all that kind of jazz. Go for results. And by the way, by getting results, you will force the data to do what it needs to do for you. And by the way, if you want that to happen, we've got slave labor extraordinaire. Every university, if we ask them to deliver against Inspire, if Inspire demanded from our college students, look, here's the data, would you guys do something with it? Here's what we'd like to see you do with it. By the way, use your imagination. You do something else with it, and the best of you, we're going to provide something. You know, whether it's a free trip, whether it's money, whether it's awards, something. But if you want results, they're ready. And I will show you an example of what I'm talking about and why and how it works. Today, I'm going to discuss WebWorldWind. No, I'm not going to discuss WebWorldWind. I'm going to talk about wildfire management tool. This is something that's free and open that uses meteorological data, uses land cover data. It's using the data, and it's not saying, hey, let's figure out how I can use the data. Let's talk about protocols. It's doing things with the data that are solving problems, and it's doing it open, it's doing it free, and if you want to do something else with this platform, it's yours to do with. So what I wanted to show real quick is a website that is right here, I hope. Yes. Okay, on GitHub, there's a website called NASA Whirlwind Research. And it should say ESA, NASA Whirlwind Research. We got to fix that because ESA is an equal partner in the development now of the WebWorldWind platform. But if you go there, you will find these applications, Quake Hunter, which is a geological society application doing subsurface representation of 100 years worth of seismic data for the entire planet. If you are into earthquakes and stuff, an extraordinary tool. We also have a thing called World Weather. Talk about harmonization. We've got 16 planetary data servers, all the open ones that are available and working right now, all brought together, and you can have multiple globes all showing different layers, hundreds if not thousands of layers of the data that's available right now, harmonized. We don't have to talk about harmonization. It's harmonized. It's harmonized. Stop talking. Deliver results with it. You keep talking about it, we're never going to get there. So, and it's not your fault, it's all of our faults. We're not demanding enough from ourselves, and we're not demanding enough from our students. The WorldWind Explorer, I'm mentioning this one specifically because this application that we're going to talk about today, and I'll just go to it. So don't forget, GitHub, NASA WorldWind Research, all those things are free and open. And go back to the PowerPoint, I hope. I guess I got to go something here maybe. Nope. I need help. Thanks. Thanks. So this is a project by a gentleman named Bruce Schubert, and he's working in concert with the Pau Costa Foundation, which you're going to hear Marc Castellnou talk about that later today. They're doing extraordinary work. Right now, in California alone, we have 29 million dead trees. 29 million dead trees. That's a matchstick waiting to go off. The trees are weakening because of drought, beetle infestation, just drought is killing them. Combination of things, all being weakened due to climate change. Climate change is not coming. Climate change is here and going to get worse exponentially, not linearly. Look at any chart, it's going off the scale. We're in deep doo-doo. And if we do not find a way to use tools that not only solve the problem, go after the problem, help us fight those wildfires, but actually allow us to work together across borders, allow us to work beyond boundaries. And we've got, we keep talking about this harmonization and data protocol between nations. We can do that by just building tools together. So this is one of them. That's an example. The places I showed you on GitHub is another example. And if anyone here knows a city who wants to work with another city who's building an open source urban management application, please let me know because we'll be glad to work with you. It's the city of Oregon, Springfield, Oregon. They're doing it now, and if there's a city around that wants to work with us, with them, they're welcoming that. So now I want to just go quickly through the slides here. This is a mobile app, and this thing not only helps firefighters see where the issue is. Like I said, it takes into account the precipitation, moisture, air moisture, takes into account wind, takes into account slope, takes into account the sun angle because that's heating the vegetation, takes into account the vegetation type, and then it calculates how fast the fire is going to spread, where it's going to go. And so it uses these little symbols here. And the top is the head of the fire, the bottom of the triangle is the heel of the fire, left flank, right flank. And it's colorized according to severity of conditions. And more dry conditions, more elevated temperature conditions, that will go from green to yellow to red. So that's, and you can drop those in right now. You can pick this application up and just drop those in. You can put a point where the fire starts. You can put a point where the fire is. And then you can drop these things in anywhere, and it'll tell you exactly about the conditions that fire will behave at that location. It also will tell you where the fire is going to go with the more sophisticated use of this application, but at the very basic level can be done with this. This would be a handy tool if you live in the fire zone and if the community had oriented the group, the people living there, to say, download this app and we're going to keep you informed about the fire conditions so you know when you better get out of your house, that type of thing, or even which exit routes to use. This is an incredible tool that can be used for all kinds of things. And it's donated by the good graces of a gentleman who's doing this for a hobby and has for several years. It's the Wildfire Management Tool by Bruce Schubert. And This one, he did it in Java, but now he's doing this one it's a web version, so it's in JavaScript. Uses all kinds of goodies in here, very sophisticated stuff. Bruce is a world-class programmer. He actually is a member of the ESA, NASA WorldWind development team right now. In other words, I hired him 6 months ago, and boy, what a find. He's using the Campbell prediction systems. The gentleman's very experienced with fires, know how they behave, and did some formulas to describe fire behavior. Another gentleman, Rothermel, and same thing. So these are very sophisticated uses of the understanding of fire behavior. And it's just natural stuff you understand. Here's a slope, here's the fire. The flames are closer to the ground. It's obvious to see why a fire is going to move much faster up a hill. It will race up a hill, and that's exactly why. Unless the wind's blowing the flame down, and then obviously it'll slow it down, or if it's going the other way, then it'll go even crazier. So all these things in terms of fuel, weather, topography are things that Bruce accounts for in the wildfire management tool. And so it does the calculations for you. If you want to know how the fire is going to behave, it will do it. I guess he calls these triangles lookouts. And he has some things that you put in also that will show the weather in terms of wind direction and strength. And all those things you can visually see yourself with your eye, but it's actually putting those into equations in the background and making calculations so that you can run the time frame out and you can see how the fire is going to behave going into the future or the past. So you can see where it came from. This is describing the fire diamond so that you understand what those colors and numbers mean. The numbers represent the height of the flame. Higher the flame, obviously more dangerous, and it gives you a sense of how to interpret that. More just on what it's about. That's the scout is showing you the wind strength and the wind direction, wind speed and wind direction. And these are all things where you click the symbol, the plus sign for either the scout or the diamond, and then click anywhere on the map, and it'll put that thing there and then provide the information to you. So it's very user-friendly. Anyone can actually take advantage of this thing. This is some of the databases that he's using. So you can see here we've got, I think this gives you some degree of vegetation information. So you know with vegetation type you're working against, whether it's trees or shrub and what kind those are. He's got explanation for these widgets. So it's calculating the slope wherever this fuel right here, it's giving you information, well, it's giving you slope at that location right there for that particular spot. On the left, you're getting a sense of sunrise, sunset, so you can kind of figure out how much time you've got in terms of calculating heat effect. So that's some of the things he's including in this open source program that you could actually use for something else. Maybe if you want to turn this into a solar panel. Yes. Oh, yeah, maybe. Thanks. If you wanted to turn this into a solar panel analysis tool, you could use this same thing, only looking at different kinds of data. How many minutes do I have? 2. Okay. So just here's where the vegetation information comes into play. This is just a description of what's going on in terms of the analysis that's going on under the hood. An explanation of how fire behaves and why. Pretty obvious, very intuitive. More on the analysis that's going on within the program based on those other gentlemen, the Campbell fire prediction system and the equation that Professor Rothermel generated. This is the math, what it looks like, roughly. And this is the gentleman that you want to talk to and say, hey, thanks, Bruce, for this incredible gift to all of us. And there he is on Twitter, the website. I recommend you visit EMX, Emergency Management Systems is where that came from. And just take a look at what he has there. And that's, then you can actually play with it. This thing called wildfire.worldwind.earth is actually, you can play with it and just add different lines of code and see how it behaves for something that you might do with it. There's the GitHub website for it, obviously. And One other thing I'll say, if you put, instead of Wildfire in here, put in Explorer, I dare you, put in explorer.worldwind.earth, and you will see the core app that Bruce said, look, I'm building this app and doing all these cool things with it, but what if someone else wanted to do something entirely different with it? So what he did is he took all his special analytical tools for fire out, and he has the base application that he's using, and that's explorer.worldwind.earth, which is also at that same site I mentioned, the GitHub NASA Whirlwind research site. If you go there, you'll find the Explorer code as well, and then you can build your own app doing entirely different things. Thank you very much.
Thank you very much, Patrick. I think I'll open the floor immediately for some questions because we got some. Oh, there we are. First question.
Well, Patrick, just a quick introduction as a courtesy. My name is João Verde. I'm with the Portuguese Civil Protection and a wildfire researcher. I suppose this application is customized for the States. Could it be used elsewhere? Could we use it in Portugal?
It's being used in Spain right now, the Paul Costa Foundation. And you're going to hear a little bit from Marc Castellnou, who's in the back there, and he'll be able to answer that question actually much better than I can. If you would, Marc could answer that.
We are testing that app in Northumberland, in UK, in the Black Forest in Germany, and in Catalonia. So you're ready to use. You just need the same data you need to run behavior for site, just put in it and it will run. It's just in any mobile phone. It works fine.
Yeah.
Somebody else? I think we can have another question. I have questions as well, because, and certainly on the data, because that's true. You said we've got thousands of data sets available and it's just there to be used. Well, the main question is for me, for most of our users, where is the data? Is all these data in a catalog? You know, within Inspire, you have a set of catalogs connected, member state catalogs, connected to a central catalog to provide some search facility. So people, well, whether you have geospatial search engine or discovery service, or you use Google to search data. Now, does NASA Whirlwind application actually foresees a search functionality for data as well, or is it just?
Yeah,
well,
you know, this will take 30 seconds.
Okay.
I can show, could you help me just bring up the arc.nasa.gov world weather. So this is, he's typing in whirlwind.arc, Ames Research Center.nasa, nasa.gov/ world weather. And that will give you an application that you'll be able to see these, you know, almost 20 planetary data sets from NOAA, from NASA, from the ECMWF group, and hundreds, thousands of layers that you can put onto a globe. Oh,
Hold on.
You got to do world weather after that part.
I did.
Oh. So it's working. But anyway, if you need more help, just contact me, patrick.hogan@nasa.gov. I'll be glad to work with you and show you more about this. But data harmonized, ready to rock and do stuff with. And that's what and it's a really nice tool. In fact, you can just type in whether it's active fires, and it'll bring up all the different servers that actually are delivering active fires. And this is also, it's kind of cool because it shows you that's the Earth right now in terms of the day-night cycle. Active fires. And these different space, weather, academia, government, if you click on any one of those, you'll see the different planetary data servers that are available. And then if you click the down arrow on any one of these, you'll see the hundreds of data sets that are layers that are available. And if you just type it in up top, you'll see what's available on all of them. active fires. You can bring up another world that'll show you wind speed, and so you can get a sense of what's going on there. Then, what's even really cool is you go to the view options, and you'll get a legend that shows you exactly what you're looking at. And if you hit the back arrow or the forward arrow, you're going in time. So all the different data for that particular active fires, if you go back in time, you can see it'll bring up the next one. And then once you've brought them all up, you can actually play a video of the thing and have a lot of fun. So harmonized data, harmonized. Let's just start working with it in productive ways and ways, ideally, that we can share with each other, because we've got to find ways to get along.
Okay, thank you very much,
Yeah,
Patrick.
thank you for the
I think we have to wrap up and go to the next presentation. Next presentation is Carlo. He's gonna talk right. Oh, thank you. Please, Carlo, the floor is yours.
Okay. Well, where is? No, but it's not. It's not this one. I mean, I don't, where is the folder? Anyway, good afternoon. I'm sorry, Patrick, but I go back a little bit to harmonization, because I'm sorry, but I think in Europe not all the data are harmonized, but not speak a lot about harmonization. I show also some other new step. So also an application that use harmonized data. So, but anyway, I have to talk a little bit about harmonization. Not too much, huh? I'm sure. Okay, what I'm presenting more or less is one of the main results of a life imaging project. It's a project inside the LIFE program. The project started 3 years and a half, finished in December, so we are more or less at the end. And the project is mainly based on the two pilots. One pilot is the landslide along the coast area in Italy. So this application is more related to the landslide risk environmental impact analysis that we made with the landslide using inspired data. Just to give you an overview, the landslide pilot is played in two regions. One is the Tuscany, the other is the Liguria. I show you just the Liguria part. So we have organized, we designed the impact analysis in two municipalities where there are a lot of problems in 2011 when there is a big event of rainstorms, and this creates a lot of landslide. The image that you see is just the landslide of 2011, so more than 1,000 landslide occurs in one day. We're using something that's just in place, so we're using the hazard map and the inventory landslide, and then we're using the elements like the roads, the population, as exposed element. So I just explain the first part, which is the environmental impact, the landslide impact analysis that we have performed, and then we show at the end, after a small window on the harmonization, which is the result in the application. We reuse this result. So mainly the application calculate integrating the facility, utility infrastructure, harmonizing the input, all the input layer, the landslide damage index, the landslide and communication infrastructure critical element, the interaction with landslide and buildings as residential area, also taking account in different way the private and public building, the landslide versus the cultural heritage. This area is particularly interesting, have a high value because it's one of the international geopark in Europe. And then also the interaction between the landslide and the population, considering the population not in the census area, but the population relate to the building, so the real population distribution. And then at the end, we have also calculated the damage produced by the landslide in some of these elements, like roads or building. So very quickly I go to show this index. This is part of an analysis that we have performed in the application that show at the end. We create in the exposition of a transport network, so we have inside the application we can calculate the interaction between the landslide, the other map of landslide, and the different type of roads and the railway. So in some cases, we identify all the critical points that we have in the road, especially taking account the tunneling exit or the building, the bridge element that is very sensitive for the landslide. We calculate also which is the building affected by the landslide. Not only the landslide, in fact, the event creates also flash flooding that is very between landslide and flood. So there is a lot of a building affected by this type of events, and we calculate the different percentage in each municipality of these problems. We calculate, of course, the interaction with the population. I said before that we're not using the population like how many people we have in the municipality, but how many people we have in the building, so it's more precisely. And we discovered, for example, that 56% of the population building is located in other areas, so it's very interesting things. And some other element, of course, that we're performing in the analysis. Then, of course, we interacting the landslide with the particular cultural heritage. We have a lot of sanctuary or some our historical monument that we have affected by landslide. In particular, in 2011, the San Bernardino Sanctuary was not destroyed, but interested by the landslide. And another element that take in account in our analysis and we performing in the application is the how many agricultural area is affected by landslide. We are in a specific area in Italy where we have a steep condition, so most of the agricultural area is based on the terrace. So the terrace is a very sensitive element regarding the landslide. So in this case, we're performing how many terraces are affected by landslide, if the terraces are a trigger factor for landslide, and also if the landslide have create particular effect on this type element if are if the terrace is not used or used by the people. So in some cases we have a different aspect that to take in account in this type of a correlation. To do that, of course, we want to design an inspired application. So we are in Europe, we have a mandate to apply the inspired layer, and we want to design an application that is based on the input layer based on inspired, but also the output layer is useful to be in inspired compliant format. So at the beginning, we have then harmonization, because most of the, especially in my country, most of the data are not harmonized, but I think you can confirm in most of the Europe it's the same. And then we have integrating these harmonized data, interlinking the data, adding the edge value, especially for expositional element, taking consideration, for example, the damage value, and to create a risk scenario to perform the landslide impact analysis. How we do the harmonization? I'll show you just one example for the other map harmonization, but this is the same for all the exposed element, more or less. We using the map, we mapping versus the specific in this case, the hazard area element of a natural risk zone, and we produce the WMS and WFS. In this case, I show you just the GML file, but more or less is the same. And if you see in the green area, you see that we're using all the Inspire URI to encoding the information. This is quite useful because if we are harmonizing the content, then all the application can reply in different places in a European country because we're using the same terms, of course. The same is done by the landslide database, but we want to follow a more complex approach. I just spent a few words about that because our landslide database is a very huge database. In Italy, we have more than 500,000 of a landslide. And our database is quite complex because it's based on different features related between there. And we have a lot of tables associated to the database. And we want to transform the data not regarding the natural risk zone at the beginning, but versus geological layer. So we're using the international standard GeoAvalanche Basic 4 to represent the landslide. And then we transform this versus natural risk zone. So it's another part of the application that we have developed. Just to show you that the landslide database is quite complex. This is is the scratch of a landslide. So you see we have a lot of information, different level, associated by a general table and associated at different features. So the complex situation to map this versus one Inspire layer is to take into account. In fact, the first exercise that we have done is divide the database in different layers. So we identify the database versus different Inspire layers. So you see in the first part, in the upper part, what we're considering to provide with the geology. In this part, what we decide to provide in the natural risk zone directly. And then there are some other information that probably is filling in different other domains. And we decided to start with the first exercise. The first exercise is to map versus geology, to have the main information that we need to performing analysis. So we decided to use in GeoAvalanche Basic, using the natural geomorphologic feature element. So the landslide is considering a geomorphological feature, but we're using the GeoAvalanche and this type of a procedure because we want provided with the landslide also information regarding cartography, the dating, the activity, the geology, so more information than not natural risk zone. And that this is quite useful for making a very accurate impact analysis. And what we have done is a GML or WFS based on the GeoAvalanche. So you see in the green side the different parameters that we have encoding in GeoAvalanche Basic 4. I show you that in this case we have added to the geomorphologic feature also the geologic information. So with the GeoAvalanche we can produce also information regarding geological unit type or geological unit event, so we can provide more information regarding how this landslide occurs, where occurs, which is the trigger factor, so we can provide more information than not in the natural risk zone. Just show very quickly this part. The very last challenge that we can present to you, okay, we have to harmonize data, but we are sure that these data are compliant with Inspire. So the next challenge is the validation. You see here that we have validated the GML file versus XML schema. So the validation versus XML schema is positive. We are valid, conform GML file. So in most cases, you say, okay, we are compliant. But this is not enough. In fact, if you want to be compliant, you have to apply the schematron. So using the EM Plus service, validation service, integrating the GeoAvalanche basic 4 schema based on the SPIRE requirement, so using the URI SPIRE, you see that the first step of validation returns some feature that's failed. So not all the elements are valid. So in this case, with the schematron validation, we discover a lot of different wrong elements that not in the first one. So I encourage to use the schematron validation and not the schema validation. The last exercise that we have done, because we say that at the end we have also to provide information for natural risk zone, is to mapping our GeoAvalanche for natural geomorphologic features versus natural risk zone SPIRE. So we have creating the XLT to transform directly the GeoAvalanche basic 4 layer in natural risk zone layer. And this is quite interesting because we can automatically this process inside the application. So I go to the conclusion to show you the application. Inside the project, and not me, but another partner developed the application. It's a JavaScript application based on the Cesium library. And we develop inside this application specific tools to perform the analysis that I showed you before. So in this case, we show you a real and tangible use of Inspire layer to produce impact analysis. You can perform we introducing just not all the index, but just a couple of index for landslide and some other for the other pilot. But the user can introduce, for example, here, 2 different points, and the application perform a routing analysis to identify which is the best way to arrive in a place, or if a municipality, a village is close by the landslide in an emergency site. So also we not designed to emergency application because it is not in charge of our mission, but we designed to have a very efficient tools for planning, for the site to review exactly how to save the road or the landscape. So in most cases, the application, show you also another application is the possibility to create the index around the terrace or the cultural heritage, so the people can decide which kind of a buffer they want to create around the specific terrace or specific cultural heritage point. And the application created the critical situation crossing the landslide as a map with these elements. And then the user obtains a result that is a GML file or is a GML file or a WFF file that can download free of charge, in this case, and use it in other application for other purpose. So to conclude, the result of the mapping are transformed with the Inspire layer. So in this case, the application is reusable in other contexts in Europe, because if you're using the same Inspire layer, the attribute is the same, so the application running anyway. And also, it's quite important, I remark that we're using conformance with bracket, because until we not decide to officializing the validation service, we are not formally valid, but anyway, in this case, I show you that there is a real and tangible test to identify the conformant classes related to a specific target schema. Okay, that's it. Thank you.
Thank you very much, Carlo. Questions from the audience? Please.
Well, it's interesting to see your example because Cinque Terre is one of my favorite places, and Vernazza, I'll be there next week. The question is, do we have an increasing incidence of landslides going on now?
Regarding
From the historical behavior of that
yeah, but
area?
anyway, we have a program to update our data. So the data is maintained by the regional system, and then the regional system passed to us. Because more or less in Italy we have 1,000, 1,500 new landslide every year. So there is also a national program funding by the government to monitoring this activity.
Yeah, I suspect that with the drought conditions, they reduce vegetation, and then when it does rain, then there's less capability for the soil to hold the water, and that would increase the incidence of
No, but in this particular case, there is a lot of element that play in the landslide event, because the rainstorm that we have in 2011 in this area is particularly intense. Decide to draw all the rain in a very short part of the coastal, so it's very heavy condition, and it's not a normal condition that we have normally. But nevertheless, what we discover in this area is most of the terraces are abandoned, so is not used by the man, and this is a trigger factor in some case, not in totally, but in some case. And then what we have formally not discovered, but in evidence, in the last 10 years we have a climate changing at the local level, especially in this area. So more or less every year in this area, not exactly in the same municipality, but more or less in the same area, we have a specific rainstorm in the autumn that create a lot of problems. So one of the main problems is the climate changing, the local climate changing that create a very intense rainfall in a short time, so changing the dynamic condition.
Thank you very much, Carlo, for your presentation. You made use of the NZ data model. Did it cause any problems to you, or was it fit for purpose?
No, we have a lot of problems, of course. The harmonization and the use of data has to analyze case by case, because each data have a particular story, especially in my country, because each region have a not different system, but different approach to realize the database. Also in the case of a landslide, we are the national authority, because we are the Geological Survey of Italy, and we give the general rules for the region, but then the region develop a different database case by case. So the main problem is to harmonizing the view and to identify the flow. Then, considering, for example, the landslide database, it's a huge database, so when you have a very complex database, the transformation or the use of the database in a specific context is something that requires a long time to analyze. We're not finished formally.
My question was more, is the data model from NZ fit for purpose, or does it need...
No, okay, regarding the data model, I mean, there is a different view. My view is to not change your data model, but transform your data in a compliant format. So, because in some cases, the transformation of data model, it's a pain. Sometimes it requires a lot of time and different transformation system. What normally I suggest to use, depend to the case by case also in the transformation. If you have a very simple database, the most simple solution is to transform this data in a conformal way, and there is a lot of tools that you can using to do that. In the project we use in AIL, that is an open source that help you. But when you go to the complex database, I think so the application scheme, they use, for example, we're using the application schema in GeoSurvey. So we are remapping table by table the element in the target models. And this is more efficient because I not need to rebuild my database, but just exposing a conformal class. So in this case, I'll pass also to respond in other case that the national requirement, for example, in the national requirement, we need to provide cartographic layer. In this case, for example, commercial software is more efficient for producing cartographic symbolization than not the open source. So we prefer to maintain the original one and transforming just the layer to compliant format. So it's not a pain. It's pain, but not a lot pain.
Okay, thank you very much, Carlo. If you got more questions on I think we have to wrap up, sorry. That's the last question. We have to go to the next presenter. It's very interesting, and the discussion on harmonization and interoperability will go on. There are a lot of people having troubles with making their data interoperable and harmonizing data according to the models. There will be a fitness check and an exercise of reviewing existing models to find the best balance between interoperability, cumbersomeness of implementation, and ease of use, because in the end, and that's where I follow Patrick as well, the essence of all the data, it has to be used. It's a pity we can't find all the applications. The next presenter will also present an application on the use case of avalanches. Now, in Inspire, you find a lot about data, but you find very little about applications. As an end user, it's always nice to find applications as well, to know which application is available for me for my use case. So that would be some of the things we could address for the coming months. So thank you very much. Carlo, Francesco, please.
Yeah. Thank you. Good afternoon, everybody. Sorry.
That doesn't look good, does it?
Yeah, it's a live presentation.
Oh, yeah.
Please help me.
We had the problems.
No. Copy. Yeah.
Oh, it's supposed to come with the URL. I was going to copy and paste.
Copy. Yeah, please.
Yeah, okay.
You have to add.
I might add. Why don't you add the
Sorry.
a semicolon / after the HTTPS?
Yeah, just add slash.
Then your browser might identify this as a
After
protocol.
Yes. Yeah. Yeah, and.
Yeah.
Yeah. No, it's not enough. It's not enough. Yeah.
I don't.
Yeah.
This shift on here doesn't work.
No.
Yeah, the shift buttons aren't working. I don't know.
Sorry, I need to do a copy and paste.
Oh, looks great, Francesco.
Okay.
You're up and running. Okay.
Sorry. Good afternoon, everybody. I will talk about the project for a GeoAvalanche spatial data infrastructure, and a little bit about, just at the end, about harmonization. Just quick words about my company. We at GeoBeyond, we we develop geospatial solution and identity and access management system. We are partner of Boundless Spatial, and also we found RIOS in Italy, that is the Italian Professional Open Source Network, to educate people to use and develop open source software and use a lot of data and much more use open data. So I love the words from Patrick, and I want to show you something that you could do with data. A quick introduction about GeoAvalanche. In principle, it's a spatial data infrastructure for snow avalanche information. There is a free geoportal at geoavalanche.org. You can sign up. The stack is entirely based on open source geospatial building blocks. We use GeoNode as a geoportal. We use GeoServer, and we use Ushahidi for the crowdsourcing system. We have different applications that can exploit and produce open data for scientists, for early warning services, rescuers, and the public. I will show you in a while how we can use Copernicus raster imageries and OpenStreetMap to build a cool application about the avalanche risk. And in that application, we use a lot of geoprocessing to ingest imagery into GeoServer. There is a custom GeoServer developed for GeoAvalanche. GeoAvalanche itself, the core of GeoAvalanche, is a custom GeoServer. And we collect imagery, we collect, ingest user-generated content from the crowdsourcing system to process an avalanche risk locally. So the user can simply draw a point in a map, or as well a route, or geocoding a place, and search for the local avalanche risk. How? Essentially by geoprocessing the terrain. So we can produce slope, we can take into account the slope, the aspect, the curvature profile. If there has been in the last days an incident in that location, and also the land cover classification also from Copernicus. And all those information can establish the avalanche risk locally. And all the code, it's GeoAvalanche, it's an open source project, and all such code is on GitHub. You can download. We are in the process to release the application to GRC because GeoAvalanche has been awarded by the MyGeos competition. So stay tuned, and you will see live the web application. But I'll show you something picture about that. Just a quick mention about the architecture. Simply, the architecture is based on OGC standard, so we can we can use WFS, we can deliver maps through WMS, we use WCS for imageries, and we use WPS to geoprocessing data. And this is just a an example of the application that I was mentioning before. Essentially, the user can draw the route in a mountain place and can establish the risk locally. Behind the scene, there are a lot of WPS processing that calculates slope, calculates the aspect, the curvature, and essentially calculates the avalanche terrain exposure on that location for a route or for a point. So we use OGC WPS for calculate the local avalanche risk. We calculate the terrain exposure index from the Copernicus digital elevation model and the land cover classification. And also we collect snowpack data from the Crioland mission. There are a lot of data about snow, and they are available through an OGC standard, the Earth Observation WCS. So we collect a lot of time series about snow parameters, and we ingest such data into the model, into the process. We use also into this process the data collected and reported by the users. So also the crowdsourced system is freely available to the public, to the agency, and the agency also can sign up and can validate the data that has been reported by a user. And so such data, once it will be available, they can be used by calling an API. So they are actually ready to be ingested by a process. But now let's go towards Inspire. There are also a bit of avalanche model. There are an avalanche domain where the community has established standard to share information about avalanche. Essentially, every avalanche has a place, a shape, and a path, which can be spatially described. And I don't know if you already know, but actually there are a markup language for avalanche data. And such language can describe avalanche bulletins, the activity comments, the closure, and the incident information, and also observation about avalanche as no profile. That is CAMEL. CAMEL is the Canadian Avalanche Association markup language. It's not an OGC standard, but it's based on GML application schema. It's actually itself, it's a GML application schema. And there is a profile for the European countries. They have established an European avalanche warning service profile schema. So essentially, the European agency that treats avalanche data can use a profile specifically built for the Europe. This is, for example, a feature type for the bulletin that has valid time, bulletin measurement, metadata, the validity of the time frame for a bulletin, and also a location. And location can be a point, or can be a polygon that is describing a region, or essentially just a place in the nearby of a route, or just a mountain, for example. So what is the EAVS profile? EAVS is the European Avalanche Warning Services. It's a sort of association of all avalanche warning services in Europe, and they maintains the profile, the GML profile for camel. So in such profile, the elements have a scope limited for Europe. But why they defined a profile for the camel application schema? Because the camel application schema is complex, and they won't just define, for example, the danger scale for a bulletin in a specific way for the Europe. For example, because the danger scale of an avalanche is different between the United States and the Europe. Seems strange, but it is. And what is the relevant part in terms of Inspire? It's that we can use such camel application schema and the profile to mapping the element of such profile into the natural risk zone. Very easy. I want to jump this slide because you you want to see and hear about it.
Oh, that's a nice slide.
But just, yeah. But just a quick, words. Obviously, an avalanche is related to the natural risk zone of the Annex 3. Sorry. And what is the most important part for the avalanches? It's the risk. It's the risk. The hazard multiplicates for the probability of the occurrence and the vulnerability. And so essentially, data and avalanche warning services are relevant in the risk assessment and the emergency management, and can use the model and the harmonization towards Inspire. Because obviously they have to collaborate in cross-boarding terrain. For example, there are a lot of routes in the north, in the Alps, where the tourists can cross the country. They start a route in Italy and they finish the route, for example, in Austria or in Switzerland. And this is actually the danger scale. The slide was EAV's danger scale, but I wanted to rename it level of risk, because level of risk is the element in the natural risk zone team. And this is actually a simple transformation based on the camel profile for the natural risk zone. So essentially, the camel profile is already ready to be mapped into the natural risk zone. But we have to educate people, we have to educate agency in using open source software, open data, and to collaborate. So yeah, the challenges is involve as much as possible the parties as they are the legal authorities and own the source camel schema and profile. They maintain the profile. I can change because essentially they work with the data and they have to know and they have to define it by collaborating with open source software how to model the data. But they had to be educated to use existing open source technologies and to produce OGC and Inspire compliant dataset and services. That's all.
Thank you very much for this nice presentation, Francesco. Are there questions from the audience? In the middle. Yeah. They're bringing a mic for you. Yeah.
Just a quick one. On the crowdsourcing aspect, I think there's a commercial company that makes an instrument, Avalanche, that is also has some crowdsourcing in their application, and I wondered if we're harvesting from each other or if there's any relationship there.
Unfortunately, not. But I know them. Yeah.
I have a question myself as well.
And I don't know if they have applied some kind of license in the sense that our data can be reused in third parties applications. Never checked, but yeah, I'm happy if they do.
Small question. We got two presentations from Italy, and they're talking about national risk zones. The one is for avalanches, the other one is for landslides. Now, I can imagine when I live in the mountains in Italy, quite interested. I would like to know the risk for avalanches and landslides every day. So I think you both provide APIs. At least for the avalanches, you're going to provide an API based on the processing service. I don't know if you will provide an API for the landslides. Probably not, just a map. It would be nice if you had an API that people could build as an application and gather all these processing services in one application as a risk assessment for people, the public living around, proving the benefit of Inspire. No, it's good, but it's good if you could answer both, if you're working together, collaborating or whatever, that's, yeah.
Yeah, I think.
And regarding the landslide, we not performing APA, but what we are planning, is to we are in the moment we are in charge to involve all the national hydrographic district, that is the authority responsible for flood directive, and to use a common tools and common approach for that.
Yeah, that would be nice. If you can also include flood, then you've got a nice set of assessment tools for societal, economical, and environmental benefits through simple applications. That would be very nice. Yeah. But, Patrick? Quick question.
The resolution for horizontal vertical for the Copernicus terrain data?
What kind of data from Copernicus are you?
Terrain data from Copernicus?
Yeah.
What's the horizontal vertical?
The elevation model or the land cover? Elevation model is 30 meter.
Horizontal?
Yeah. And land cover, if I remember well, was 100 meter. Yeah. 2012.
Because the new one is 20 meter.
Land cover?
The new Sentinel production is 20 meter.
Good.
Okay, let's wrap it up.
Thank you very much.
Francesco. I want to give the floor to Marc Castellnou in the back. He's going to present us the European implementation of a NASA WorldWind that Patrick presented as a first presenter today. And he'll show us that this platform also works for European use cases. looking forward to it. I will present the paper to all the presenters to fill in, to actually, well, waive your property rights on the footage that we're shooting from you. So, Francesco, you have to fill in a paper form for me. So, please go ahead.
I'm just waiting for PowerPoint. Launch. Well, I will present you more or less where we are going with application such the one Patrick shows you and how we are using those applications to confront the multi-emergency management in areas where we have a lot of emergencies going on at the same time due to natural disasters and human disasters. So what I am not going to show you is code or programming or anything like any platform. I am firefighter. I am an end user. I am not developer. So sorry if I disappoint you on that. But we work with our European projects like FAROS, funded by European Union, with all the management of the data and harmonization and so on. But we are focusing on big problems like this one. You are in the city of Barcelona. It's surrounded with a lot of forest, a lot of green around, and a lot of people living in it, and a lot of economy going on there, and a lot of things at danger, and a lot of defensive situation from the emergency and rescue services. So that's our map of wildfires during the last years in that area. So it really is a danger, and it really is a threat. But the main point for me is not, I don't expect any applications to see what the fire will do. That's solved. I need to make decisions how I solve a situation. And my main problem right now is that I am, in the last 30 years, I went into a business where I was being paid for protecting forests, and now, lately, I'm paid from protecting people's assets from forest wildfires. So situation turned around a lot in the last years. So that's a picture of what's the real situation right now when we come to fight fires. We are retreating. That's reality. We cannot longer say, we will protect you, citizen, pay your taxes, we'll fight for us. No. Right now, under climate change conditions, fires are overwhelming us. We need information to predict what the fire will do, but not to try to think to solve the fire, just to try to not to lose too many things. So fires are burning more than we can fight. So situation is not that tools will help us to fight fires. Tools right now, the tools we are waiting are, we are expecting they will help us to, okay, let's see if that works, okay. We're expecting to help the tools to make better decision making. So to see how much things we can protect and how much things we cannot protect, and then try to come out with the minimum damage, not only to forests, but also to property, to persons, to traffic, to economy, to everything. So it's a complex system, and we need simplification of data to solve those conditions that are overwhelming us. I'm just putting you some videos just to, because normally people don't realize that the reality of the problem is that big. So those are firefighters that are protecting themselves again from fires. The question is that when it comes into urban interface area, you are not there to fight fires. You are there to protect things from fire. So you need a really good decision system to assess your firefighters, because trying to protect things, they end up protecting themselves because there is no solution for the problem of the wildfires under the climate change paradox we are living on. And that's the type of environment we end up in right now. So the fact is that we are expecting us to be in a certainty position, but normally we have a lack of fighting capacity because we used to have a lack of resources. So naturally, the strategy has been to give us a lot of resources, but now we need better adapted tactics to avoid uncertainty, to avoid things we don't know. So that's where traditionally resources came in to provide fighting capacity, but now technology, data, drones, layers of data, a lot of simulators, a lot of tools came to provide us information to reduce uncertainty of what's happening, so situate or provide us a position of certainty where we can fight fire. And that's more or less what the solutions like the one Patrick shows us came into, or this one, which is a normal wildfire simulator that shows the fire paths where we can position ourselves to fight fire and everywhere. But at the end, we end up with infotoxicity. It means a lot of information we cannot manage that collapse our decision making and increases our uncertainty. And when we have a lot of uncertainty, then is where we have lack of decision and accidents. And that's more or less what happens right now. All the data, if it is not packed into things we can use in the decision moments you've seen, then we have decision lag. And the decision lag is more or less that information is resolution of uncertainty. The more information you put in, the more uncertainty we have because bigger management systems of data we need to provide better information. And then we need to focus, and that's the main problem we have. So you've seen the Patrick and Bruce Schubert application. They did this great job. We just translated it into that type of situation. That's more or less the same graphic of the diamonds, but using arrows about what the fire behavior will be. Red is difficult to fight, and you've seen yellow, if you try, you can maybe fight it. Green is, if you go there, you will put it out. That will be the spread of a fire. That's the minimum of spread of a fire. And that's the maximum spread of the same fire. So for me, data that provides me the information of what the fire will do, like this one, it's good, nice, but not useful. Because now what? You have a really high fire risk day. Okay, thank you, good information. Now what? There is a fire, go and fight it. Well, I cannot fight it. Well, nice application, but at the end, everything burned. So we need to know where is the right information we need to provide firefighters, and that's where I will, a basic example. What if firefighters go left flank and put that fire out where they can, which is yellow and green? They can do it. What if they go this area, which is green, and they can do it? Which do you think will be better? Go left, go right? That's the decision. That's real life. So if they go this side, that's what the fire will look like. If they go the other side, that's what the fire will look like. So at the end, the decisions they'll make will last more than they will live as a generation. And that's the reality. We are not asking for information to help us protect what we have. We are asking information to help us decide what's the better option we can have, because what we will do will change the landscape for the future to come. And in this fire, as you see, and you see a lot of red, you see that it's, here you have a lot of red, and there you have a lot of red. Red means I cannot fight it. So for me, the best solution will be go and fight the right flank, because then you will end up with a fire. You will be able to fight there and there. So it will be a safer fire for me to fight, for my people, and will be a fire with a lot less uncertainty. And then if you don't use surface and you use values in the country, then things looks better. So that's what we are doing with the platforms. And that's we as a firefighter, how we use the data. That's another fire. That's nearby Barcelona here. So the situation is like this one. If you go and protect the houses, you don't stop the fire, and the fire will keep affecting houses. If you go and fight the fire, some houses will burn. So you need a decision-making system that will tell you will be the better outcome in terms of reliability and in terms of losses in the ecosystem and the houses and the economy and everything. So it's not only we need to know what is happening or what can happen. We need to know or introduce what will be the solution, the best solutions according to the values that we are involving there, and the capacities we have to fight fire means uncertainty. So everything is needed to provide a little bit uncertainty. So that's the way we transform in Europe the simulator that you've seen before. So we break the landscape into pieces, and then we create the connections into pieces, and the color of you have in the arrows are the same than the diamonds you've seen from Patrick. And that's a decision-making system with all the values involved. But not only the local picture, also looking at the bigger picture, where you have the same fire there in the number one, and the same decision system with all the surrounding. So we don't decide for solving the problem we have now, we decide for solving the big problem we will have if we fail. We have to fail the first problem. So we need data for the bigger picture. We need the connections. That's what we are looking for. So we are transforming, let's screw up again the presentation with the format of the letter. Anyway, we transform the landscape into pieces of travel time for the fire, capacity of firefighting, and value, emergency value. And that means 3 means that's the value of all things that are in there, or 4, that means that it's 4, it's valuable than 3, and 3, it's valuable than this one. So it's introducing all the decision-making systems, because at the end, and that's the same graphic of a fire, the same fire you've seen in the video, at the end, those are the connections of all the pieces with all the capacity of firefighting, and that's the graphic of decision-making. I'm sorry, but during the first hour and the second hour, my firefighters will lose almost 50% of the total landscape and value that is in that area, and they will have to confront 6, 7, and 6 decisions in 1 hour time. It means more than 20 decisions to make. That means they will fail for sure. So that's again how we start to look at it. It's making the maps and say, okay, at the end, 100% chance of losing the landscape. If you do that right, flanking the fire in green areas where you can, you will lose for sure 57%, and then you will have chances of, say, 7% or 11% or 25%. But using the same system and changing, just managing part of the landscape, then you change from 100%, you will lose only 35%. 43% will be safe by fire service, and 22% will be safe because you manage that. So at the end, what we are doing, again, is providing certainty using the system. We are looking to situate it, not only the resources into certainty, but the tactics, and the tactics based in values, and the values based in what firefighters can do. If we do that, we are only not doing the decision-making in the day we fight the fires. We can do the decision-making before the fire happens, because the system works all the time when you have the fire, but before having the fire, just supposing what fire you can have. Then you provide people with decision-making, not to use the data to understand the situation you have, but using data to understand the situation you are heading to, which is the important thing in emergency management, and simplifying the problems I will be facing. Because at the end of the day, I have to drive my firefighters to produce the lower emergency possible, but I cannot do that. I have to solve all the emergencies. I need to make everybody aware, and that's where WMT comes into in Europe, and how we are using to provide a logic of how emergency will spread to the landscape. Thanks.
Thank you very much, Marc. A very nice presentation. Nice system. Also raising awareness, and I'm pretty concerned about the estimation of value, because I didn't see any value maps for vegetation, species, or and so on, landscapes. So you talk mostly about assets to start with. So that's another, it's another kind of priority sets. So I think the environment is less priority than probably assets are. So that's it's kind of difficult to accept at a certain point, but I can imagine that it's part of the daily business. And if you have to make 20 decisions in a half an hour to actually protect some assets based on a value scale that you provided, then priority will be on environmental value will be pretty low, unfortunately.
Yeah, well, in that point of view, we have to be aware that if the values we protect are mainly the private values that what people owns, our system becomes a system that protects the private property or the people that have more things. And then if we want to be a democratic public service, then we can have to protect the common value. But that means that using those systems, we must tell people that we will not protect them because we will be protecting the common value. So tools and data are there to reduce uncertainty. The worst thing is leaving people with uncertainty of what will happen in the fire. If we can tell them that's what the fire will do and that's what we will do when that will happen, because that's what we can do and that's what we cannot do, then things can work better than right now. That's the point.
I guess you use the same system for forest management. Or
yeah, that's forest management. But the question is that using that data properly, we can change a defensive situation. It means we defend what we have now to a creative situation defining the landscape of the future. That's the point. And we not have to use that because we can no longer invest more money and resources in defending. We need to change the situations. Because when I started to fight fires, fire used to run 1 kilometer per hour. Now they run 12, 15 kilometers an hour. So it's something we cannot do anymore.
So thank you very much for giving us a lot of insights in risk management, certainly from firefighting point of view. And thank everybody else for the persistence. I want to give the floor to the last speaker of today. Yes, he had to wait for a long time, but welcome, Fabio. The floor is yours.
I have to say, I'm not Fabio.
Fabio
couldn't make
Fabio,
it, so I'm Neil. Alrighty.
No, but you can sign for Fabio, then we make it on the footage. We say it was Fabio with a strange accent.
So I think I've got like minus half an hour for this talk, so I'll try and be as quick as I can. But I have to say this is one of the most interesting sessions that I've had so far, so I'm enjoying the talks a lot. So I guess this is going back to the first talk here, which talks about how, we've got the data, we've got the harmonization, we need to use it. In the project, the WeSense It project, which is just about to end tomorrow, the problem is we didn't really have the data. So we had some data to solve the problem, and the problem was related to water, droughts, floods, quality of water, etc. So what we wanted to do was see if we could use the citizens to try to gain this data. So the traditional way of doing things is to use fixed in situ sensors to measure water layers, water levels and flows, and rain and wind, etc. But these are very isolated, they're relatively expensive, and obviously you get point readings. So we wanted to maybe develop ways where we could get dynamic data that would enable us to get the sort of measurements from the places that we actually wanted them. So this is just an overall view of the project. The idea was to, as I say, use people or social sensors, and also to use physical sensors. And these things would be combined in a network in some way. We would develop models which would be able to combine these two forms of data. And this would go into a decision support system which would enable us to do something when flooding happened, or etc. And this was all built on a technological infrastructure. As I said before, we have remote in situ sensing. So this is a thing which is traditional. So we had a number of these which were brought in prior to the project. And we also looked at developing new novel versions of these things which would be cheaper, and therefore, you know, if we could drop them an order of a magnitude, then potentially we could have 10 more out in the field and have better readings. We had things called passive sensing of the citizens, where if we monitored the citizens but without their engagement, could we get some information from that? We had something we called opportunistic sensing, which is when the citizens generate some data, but not for the purposes that we want it. Can we then exploit that data in some way for the tasks that we want? Then we had participatory sensing, which is basically where we actually ask people to provide us with the data, and we developed a number of ways of doing that. And then we had another group was involved in the modeling and combination and prediction and visualization of the stuff. So during the whole project, we wanted to look at various ways we could bring people into the process of monitoring water. And this went all the way from them as just people right up to them as engaging in the scientific process itself. So the idea was to bring these two people together in some sort of combined system, a citizen observatory of water to improve the overall performance. So as I said, we looked into a number of processes. So the idea of opportunistic sensing was the main thing we did here was to look at social media, the chatter on that, and see if we could extract any useful information. So we did a piece of work where we looked at how people were talking about the weather, the rain and stuff. People like to talk about the weather in the UK, so it was quite easy. We took this information and we tried to correlate it with the actual weather that happened, the amount of rainfall, the amount of snow, the wind, the temperature, and see if we could actually use the chatter to get a kind of a cloud image of what was going on rather than a bunch of points of rainfall and wind, etc. And you know, we have various papers on that. The other way we want to engage the citizens is actually get them to attach various sort of devices. So one of our partners came up with a way of measuring rainfall acoustically. So you could attach this to an umbrella, and then they could go out, hold up the umbrella, then we could get a indication of how heavy the rain was falling. Again, this was a nice idea. It didn't really work. Obviously, you could say if it's raining, they've got the umbrella up, so you don't really necessarily need it. You know, if it's not much rain, then they probably won't bother taking out the umbrella anyway. So then we had looked at something as measuring river levels and snow depths by inserting basically a tape measure in the river or where it was going to snow, and then we get people to go around and they can read off the measurements. The idea behind this is it's incredibly cheap. You know, you only need to spend kind of £10 on a measurement stick and provide people with an app or a website. Then we also experimented with more complex ways of engaging with people. So we looked at developing a way of measuring river flow by taking a video of the river, spotting how fast debris and various things in the river were moving, and then use that to estimate the flow of the river. Again, this was very much a research process, but the idea was this is a potential way that people could engage. And then we looked at even more scientific implements. So there's a thing called sensible heat flux, which measures something to do with the way evaporation happens. And currently, these type of systems cost 5,000 to 10,000 euros. We looked into ways of making these cheaper, so you could put them on more weather stations, because this is apparently an important measure. And finally, we had a group that was looking into how you combine these two forms of data. So I think this is one of the big problems is that people collect data from the citizens. We've had a few talks over the last few days about this, but the actual combination of the classic data from the sensors and the people data generally never really happens. There's various reasons for this. Mainly the scientists like to have data which is a nice clean format. So they like to have data which hits every single time point and has a value, and that value is consistent. It's either consistently wrong or consistently right, but they don't mind as long as they've got it, you know. And the problem with the data we get from people is that it doesn't happen all the time. It's incredibly variable. We don't necessarily know who we're getting the data from, how good they are. So when they come to make their decisions, when they come to you know, there's a large amount of uncertainty in the data, and, you know, as we've heard, you know, we don't want that. You know, it makes the decision-making process more complicated. So in the end, we kind of looked at ways of engaging the citizens right along this spectrum, right the way from little or no engagement, right the way through to highly motivated people, so people who worked for the organizations that we were interacting with. And what we actually initially thought that, you know, from the right-hand side, this is where we'd get the good data, this is where we'd get the stuff which we could use, and, you know, the high-quality data. And down this end, we would get junk, and maybe it'd be interesting, but, you know, we wouldn't be able to do it. And actually, it turns out that after 4 years, it's the other way round. So actually what we find is that if we develop tools that enable us to get data from people with little engagement, we can get data consistently, and we can get data. We can get large amounts of data, and although this data is not high quality, although it's not necessarily directly in the or directly related to the tasks that we want, because it's large, because it's consistent, because we can process it, this turned out to be kind of more useful data than the data we got from the highly motivated people. Not to say that wasn't any use, but it's just not necessarily the use that we wanted. So the data on the right-hand side is good because, you know, they provide pictures and you can look at the pictures and interpret what's going on. They provide a story, a narrative. You can engage people. You can use it for education. You can use it for lots of reasons, but not necessarily for the process reasons. So, for example, one of the things that we kind of developed during this project and involved other projects involved monitoring people's activity. So we had a bunch of projects and they involved giving people a mobile phone, and it would tell them how far they walked, how much energy they were using, you know, and we engaged these people running competitions. So there were competitions in the city which we were working in and between cities, and this kind of took off, and we got all this data about where people were, and actually we could find out that this could provide us with a bunch of other stuff as well. So, for instance, we could look at the areas of danger. So we could look at where flooding was likely to happen. And we could see at various times of day, we could see during various conditions where people would be. And so when it rains, people don't go out to the park, they go shopping. So if the flooding happens during that time, we happen to know that all the people will be over here, or all the people, you know, and that would happen on a weekend, and if it happens during the day, they would be over here. And this would potentially enable us to, when the flooding occurs, we know where the people are, we can make the decisions which were based on that. And also we did other ways as well. So if we had this data, we could kind of combine that with the participatory stuff. So if we have our city, we have a bunch of data about that city, but there are certain places we have no data about. If we know these people are passing through that area, we could potentially ask them to provide the data when they are in that area. So rather than annoy them all the time with asking them, we could only ask them for information when we needed it. And a bunch of other stuff. So the final outcome was basically that you know, that the way you engage with people in the end turned out to be not the way we expected to. And those people who were highly motivated provided us information, but not that information we could really use. And the people who weren't in the system, but we could drag into the system by various sort of means, those people provided information which we could then combine with the more sort of classical stuff. So, thank you very much.
Very interesting presentation, Neil. Thank you very much. I really like the way you put all the information together, because you didn't mention it, but you got a lot of population statistics as well, demographics that you're using based on the location of devices, but you're gathering them to actually find out the location of people at a certain time and the risks that you're actually making a risk assessment map, but based on very actual data.
Yeah, it's always nice to get to the end of a project and not be where you expected, because it's a bit like if you end up being where you think you're going to be, then you kind of think, well, why did I bother doing the last 4 years? So it's quite, it's quite good that we ended up somewhere different.
So maybe there's still some questions from the audience on this topic. I don't know. Nobody? Last one, because we're closing up after this one.
It is tea time. Yes.
No, then I'll thank you, Neil. Thank you very much. And thank all of you for staying with us until this late hour. And a lot of thanks to the presenters for this real nice presentations again. So, sorry, a favor. So, last round of applause.